Good morning, everyone. It's fantastic to be on the IP Showcase boat. My name's Rob Porter. I'm from Sony Europe BV. I'm also acknowledging my colleagues here, Jonathan Thorpe and Simon Lowe, without whose work this presentation would very definitely not be possible. I'm going to take you through the latest developments in AMWA NMOS and explain how it's all powered by open source and how that can help you. So let's just move to the next slide. Yeah. So I think everyone's familiar with the basics of NMOS, but I'm going to give a quick summary anyway. NMOS is very well established now within facilities, within the studios and the OB trucks, what we call on the ground facilities. And it's mainly used currently for making connections and discovering devices that are sending and receiving ST2110 flows. Very widely adopted now. You could almost say it's the kind of established standard for doing that within facilities. Very first standard from NMOS was ISO 4. Don't ask me what ISO 1, 02, 03 are. ISO 4 is for the discovery of media nodes. So the idea here is the kind of plug and play functionality you get when you first plug your media node, be that a camera or a monitor or a vision mixer, into your IP network. It will first of all discover where the ISO 4 registry is in the network and then register with it using the registration API. And then a controller or a routing panel or routing panel, depending how you pronounce it, can find that registry and use the query API to discover all those connected devices on the network. The controller can then make connections between the devices on the network using the ISO 5 connection API. And in this case, it will first of all talk to the sending device, the camera in this case, get all the transport parameters from that device, in particular the multicast address that that device is sending out on. It can then patch all that information to the receiving device, in this case a monitor. The monitor will get itself in the right state to receive the correct format of video, and then it will do a multicast join to the network, an IGMP join, for example, and start receiving that flow over the network, and we have a connection. So that's ISO 4 and ISO 5 as we use it today for media networks, and that's all hopefully working very nicely for everyone. But NMOS goes beyond that. We have some other specs that are also well established. Just to briefly run through these, ISO 7 from a few years ago now is the event and tally specification. This allows you to send events over the network using either the WebSocket protocol or an MQTT broker. And the advantage here is that a single sender can be multicasting those events or tally information to multiple receiving devices. So you're effectively, those events are multicast in the same way as our other flows are, the video or the audio flows. And so something on the receiving end, in this case a camera, can receive its tally information. You could also have a controller receiving information about changing parameters on the network, audio levels, that kind of thing. So it can be used for all kinds of things and is fairly well adopted in some specific circumstances. ISO 8 we have for audio shuffling. So in this case, we're just replicating the kind of audio shuffling functionality we're all familiar with. And this can be used, for example, if our sender is sending out 16 channels, but we only want to use a particular 2 channels of that for a stereo in a particular language, for example, we can choose how those channels map to each other from sender to receiver. Then we have ISO 9. This is quite an important one for system information. Here, any media node on the network can discover the system API and get some key information, such as the PTP domain number for timing, or importantly, for NMOS, the registry heartbeat interval, so it knows how often it needs to send the keep alive signal to the ISO 4 registry to let it know it's still on the network. So that kind of core global information that every media node needs to know can be obtained using the ISO 9 system API. And then at the bottom here, we've just got a couple of BCPs. So BCP is a best common practice, whereas the ISs are API interface specifications. The best common practice here for grouping flows, 00201. That, for example, allows you to kind of label up your flows to show how they're grouped together. So you could have an associated video, audio, a metadata flow that you want your controller to understand. It should really route together from sender to receiver. So one use case is you have an SDI to IB gateway, which is capable of converting many legacy SDI devices into ST2110, and your controller needs to know how all those different flows should be grouped together when it's doing the routing. Another well-established BCP is 00401, and that's for allowing a receiver to express its capabilities. So before we had this, a controller could try and make a connection between a sender and receiver, but it wouldn't necessarily know that they were actually in the same format and that the receiver was capable of receiving what the sender was sending in terms of whether it's 4K 60p or HD 50p or whatever else. So this receiver capabilities spec allows the receiver to express that within the ISO4 capabilities information, and so that's all stored in the registry, and the controller can get that information and make sure the two things are compatible when it's making the connection. And then finally, in terms of established specs, we have the security specs. This is the BCP 003 family of specifications. 01 here is the transport layer security. So NMOS is basically a web-based protocol. It's HTTP over the network. 01 just specifies you use HTTPS instead of HTTP. So it's that familiar padlock on your internet browser. Make sure that it gets from one end to the other without being able to be tampered with or hacked, basically. 02 is for authorization. So in this case, what we're trying to achieve is that only users or clients or controllers that are authorized to use a certain NMOS API are allowed to do so. And for this, we use tokens. So as well as sending over HTTPS, we also have to include an authorization token in our headers when we make these API calls. And that ensures that we can make sure only users that are allowed to access these devices, or other devices that are allowed to access other devices on the network, and so on. So we've got the BCP that explains how to do that, and then also IS10, which is the authorization API of how you actually get those tokens. And finally, 03 of the security specs. This is the certificate provisioning best common practice, and this just explains how you provision these certificates used for 01 in a timely way to all the media nodes, all the devices on the network, and how those should be refreshed occasionally just to make everything work. So how can the open source help you? Well, it makes everything very easy to adopt. So at Sony, we took an initiative a few years ago to open source our NMOS C++ software as NMOS CPP. That's available for free on GitHub under an Apache 2 license, so anyone's absolutely free to use that and incorporate it in their products. And that's got great coverage of the NMOS specs, and we're continuing to make sure it evolves and keeps up with the specifications. So you can see here, for most of these specs I've already mentioned, all but the last two are already covered by NMOS CPP, and we're working on incorporating these final two security specs at the moment, so that should be available in the coming months. NMOS testing is a collaborative effort by various AMWA members to create a testing tool that can automatically check your NMOS implementation and check it conforms with all the specs. So this is available for free from the AMWA GitHub website. There's been many different contributors to that, and it's now a requirement before we publish a new specification that it has full coverage in the test suite. So you can see we've got very good coverage for all the appropriate ones there that are actually using any kind of API interaction. And finally, the specs themselves, they're not behind a paywall. They're also open source. They're available on AMWA GitHub as well. And also there's a kind of rendered specs page here, specs.amwa.tv, where you can find all those specs. So that's where we're at the moment, where we've been until recently. What's new? Well, I drew this when the weather forecast was a little bit sunnier, imagining it might look something like this on the canal today. Maybe my imagination ran away with me a bit, but we're steadily navigating the good ship NMOS through the canals of Amsterdam into all these new areas where NMOS is extending its reach to. And I'll go through these one by one now. So NMOS, this is a really key thing now. Everyone thinks NMOS is just for making those connections, for doing the routing, for discovering what's on the network. But it's much more than that now. So just published earlier this week is IS-12 and the MSO5 suite of modeling specifications. And this is for real-time modeling and control of media devices. So this is for operational control, real-time control, and real-time monitoring. And it's completely flexible, so you could do pretty much anything with this in terms of controlling or monitoring signals from a device. The MSO5 specifications define a device model, and it's basically a tree-structured hierarchical model where any property or method that you can call or monitor on your device is expressed within this tree. Then IS-12 is the protocol that you use to do things like get or set those properties on your device, also receive real-time notifications of when those properties change, and also execute methods on the device. So this is a real kind of game changer in NMOS. This will allow us to do so much more with it. Obviously, we're looking at using it for things that common functionality that people want across their products. Another thing we could be using this for soon, and this is going to be addressed in the next phase of work, is for initial device configuration, that kind of day one configuration in the facility or outside the facility. So that's NMOS modeling, just published. The next one here. So NMOS, traditionally, as I said, it's been used within the facility, within the OB truck. Within the VSF, there's a couple of activities where we've looked at extending beyond facilities and adopting NMOS-based methods for doing this. So one of them's the ST2110 activity. This is for sharing resources over a wide area network. So this could be between two different facilities, two different studios. It could be for remote production, anywhere where you've got a kind of enclosed facility, but you actually want to share some of your camera feeds or share access to some of your devices across a wide area network. And within that group, we defined a constrained way of using NMOS based on having a gateway that exposes all these internal devices over the WAN using NMOS ISO4 and ISO5, so that a gateway in a second facility can make ISO4 and ISO5 calls over the WAN and discover whatever this facility wants to expose. It can be limited. It doesn't have to expose all its internal resources. And that's documented in TR09-2 by the VSF. That's a technical recommendation from the VSF. That same method can also be used from the ground, a facility on the ground, to another facility that's actually cloud-based in a data center. And so another activity within the VSF is the GCCG, ground to cloud to cloud to ground activity. And there we're proposing we use the same TR0902 method between ground and cloud and ground at the other end. Within the cloud itself, we're also discussing using NMOS, perhaps in a less constrained way. But the discussion is, do we really need a registry in the cloud when everything's provisioned anyway, when you know what's there? That's the kind of thing we're discussing there. But we are kind of definitely set on using NMOS to connect between different devices, or different services, I should say, within the cloud. So the third thing, NMOS no longer just for broadcast. So AIMS have an activity called IPMX, an initiative, and this is about using using open standards such as ST2110 and NMOS within the Pro AV market, where there are no open standards that are widely adopted at the moment. And to make it work, to make it very plug and play, so that, for example, when you plug your monitor into your laptop, they can negotiate the best format to use for the highest quality resolution on the screen. We've created a new NMOS spec called IS11, and this allows the controller to talk to both the receiver and find out its capabilities, and talk to the sender and find out its capabilities, decide what the best match of formats is, and then put the sender into the right configuration to be able to talk to that receiver. So it's a little bit beyond the other BCP I talked about earlier. It also has a mapping into the kind of well-known HDMI EDID method of doing that, but we're NMOSifying that now, making it all open and easy to use. And that's just been published earlier this week as well, so expect to see some use of that coming up soon. Okay, another key point, I mentioned earlier we've mainly been doing uncompressed ST2110 in the past. We're now making sure NMOS can be used for connecting devices using all kinds of other media flows. So already we have BCP 00601 for JPEG XS flows, as described in ST2110-22, the compressed layer of that. We're also looking at how we can support H.264, H.265, and in terms of transports, NDI and MPEG transport stream. These two should be coming along pretty soon. And what it's about here is how you actually define the parameters in ISO 4 and ISO 5, such as the flows, the senders, and the transport files, what parameters you need to set to make all this work so that a sender and a receiver can understand whether they're compatible or not, or rather the controller can understand if they're compatible and make those connections. And as well as all these extensions to NMOS, we're also making sure the workflow is constantly improving. So AMWA, over the last year or two, has started having a user group made up of broadcasters and systems integrators, and they're regularly getting together and telling us what we need to change and what we need to add in the technical work groups to make everything work better for them. And one really strong requirement they had was that we provide better labeling of resources in NMOS. So in the ISO 4 registry, you typically get all these things registered. If there's many of the same device from the same manufacturer, it's a bit difficult to tell what's what. So these kind of specifications are giving us very firm advice on how we should label them in a consistent way, where you put the label saying it's which manufacturer it is and which device it is and the serial number and so on, using ISO 4 tags. That's in BCP 00202, which has already been published. IS13 is going to be a writable mechanism. So whereas the BCP media nodes are kind of hard coding that information in their node, with IS13 it will allow a controller to add additional tags, and that could be meaningful information for production, such as you know, a language for an audio sender or something like that. So lots of new functionality coming there to improve the workflow. So yeah, I've told you already what we've done with the open source to cover the existing specs. We're continuing to make sure the open source is with you all the way and adding support for all these new specs I mentioned. So these latest two, the labeling, resource labeling, and the JPEG XS, we already have integration of that in NMOS CPP, thanks to our colleagues in NVIDIA. Thomas's colleague Gareth added those two, who's a regular contributor to NMOS CPP. It's a collaborative effort. It's not just Sony, I should say. We're also in the process of adding support for the other security specs and for these new specs I mentioned down at the bottom here. So these will all be coming soon into the open source software over the next few weeks and months. In terms of NMOS testing, as I mentioned, a spec can't be published until it has a test suite. So all these new specs I mentioned have test suites ready, and they'll be in the open source of NMOS testing very, very soon. And finally, I'm not going to go through every point of this, but just a little bit more history about why we did the open source and how it came about. So back in 2017, we decided to open source our NMOS CPP software at Sony with our initial implementation of ISO 4 and ISO 5. And the C++ has a registry implementation, that open source registry, which is now used at many testing events and JTNM tested and so on, and AMWA workshops as well. And also a node implementation, which acts as a library that you can integrate into your own implementation. Over the years, we've added support for many of the new specs, and yeah, we're actively working on some of those latest specs, as I mentioned. There's also another open source library called NMOS.js. This is a very straightforward to use, web-based controller that allows you to make connections between media devices on the network using ISO4 and ISO5. And we're looking at evolving the functionality of that now as well to cover some of the newer specs. Over the years as well, we've also been contributing to the specs, including the security specs. Receiver capabilities was led by us a few years ago. Another thing was the controller activity. So what we found was we didn't have very good testing for controllers until recently. So we led an activity to add controller testing to the NMOS test suite, and that was used at JTNM Tested last year. And now it's a new mandate that any new specification has to have very clear wording on what controllers should do so that we can test them properly and make sure they're behaving correctly. And we're very involved in all the latest specs, including IS-12, for which Jonathan, my colleague, led the development of the test suite for that, making sure it could be elevated to specification earlier this week. So yeah, please let me know if you have any questions. Check out the open source software, feel free to use it. Finally, I'd just like to thank my colleagues, Jonathan and Simon, as mentioned, and the many other contributors to the open source software, particularly Gareth from NVIDIA and Nikita from Matnica, who's done a pull request for IS-11 recently. It's great to be a collaborative community working on this open source software together and just improving the easy adoption of NMOS. So thanks to them.